All right, in this video, I'm going to go over compound interest. So this is another application for exponential functions, and it's one that's really useful to understand because interest can help you whether you want to buy a car and get a loan, buy a house and get a loan, go to college with a loan, or if you want to invest your money in the bank and you want to earn interest for yourself. So that is interest is really important to understand. And we're going to focus on two types right now, talking about gaining interest. So if you invest your money, how can you gain interest from the bank? And these are the two that we're going to focus on today. The first one is compounded continuously. So if you are having compounded continuously interest, you're going to use the equation A equals P times E to the RT power. And we always like to call this PERT, P-E-R-T, PERT. The second type is going to be compounded at n intervals. So this n value, that could be at different intervals per year. So whether it says weekly, monthly, daily, annually, biannually, those are all different values of times that it would happen within 1 year period. And this is the equation for that one. This one doesn't have a fancy name because it's a little bit longer. But down below, we've got all of these different variables defined. A is the final amount, P is the principal, or basically the initial amount, R is your rate, T is the time in years, and N is the interval, or the number of times a year. So for example, some of these intervals might be monthly. If it happens monthly, then it happens 12 times a year. Maybe it happens quarterly. Quarterly would mean 4 times a year. Maybe it happens biannually. That would be 2 times a year. So it just depends on the problem itself. So let's start with this first example here. You deposit $9,500 into an account that pays 8% annual interest. How long will it take for you to have $15,000 if the interest is compounded monthly? All right, so let's look at all these numbers I just highlighted. You deposit $9,500. That is going to be your initial value, or P. The account pays 8% interest. 8% is your rate, R. If you want to know how long it'll take to have $15,000, that's going to be your final amount, A. And this one says it's compounded monthly. So we're going to use the compounded at n intervals equation. And n is going to be 12 since it's monthly. So let's plug into the equation we have. We've got 15,000 is A equals P times 1 plus R, which is 0.08, over n, which is 12, to the power of n times t. And there's our equation. All right, now we're going to solve this for t. The first thing I might do is simplify what's in the parentheses. So I've got 1 plus 0.08 divided by 12. And I'm going to change it to a fraction in my calculator. I get 151 over 150. All right, now we're going to go ahead and solve this. So dividing both sides by 9,500. And I get 30 over 19 equals 151 over 150 raised to the 12t power. All right, now I've got t stuck in the exponent, so in order to solve this, we're going to have to switch to log form. And bear with me, I know we've got a lot of fractions, but we're going to start with our base here. So we'll have log base 151 over 50 of 30 over 19 equals 12t. So I'll write this up here. Log base 151 over 150 of 30 over 19 equals 12t. Finally, to solve for t, we would divide both sides by 12. And I'm going to plug all of this into my calculator, taking it step by step. So starting with the log, and then dividing that value by 12, and I get 5.728 years is how long it will take. All right, for the next one, what is the ending amount for an investment of $100 invested at 3.5% for 8 years and compounded continuously? So we need to know the ending amount. We're looking for A. We're given our initial amount P. We're given the rate. We're given the time. And we're told that it's continuous. So that's where we use PERT. All right, so let's plug into the equation. We've got A equals P is 100 times E is the base raised to the power of 0.035, which is R, times T, which is 8. In this equation, we've got all the numbers on one side. So we're just going to plug into our calculator to solve for A. So I've got 100 times E to the power of 0.035 times 8. And I get 132.31. I'm going to round to 2 decimal places since this is money. So we've got $132.31. All right, this last one here, you deposit $9,500 into an account that pays 8% annual interest. How long will it take to have $12,000 if the interest is compounded quarterly? For compounded quarterly, that's going to be n equals 4, because quarterly means it happens 4 times a year. Go ahead and try this problem on your own and check the answer key to see how you did.